Okay, so although there are multiple ways of solving this problem, I'm going to do the concrete way. And that would mean that what I'm going to do is, I know that it's a pendulum, so I'm going to be using the formula that T equals 2 pi square root of L over, let me use their variable. So they're using capital L. So L over G. Now it says that a pendulum of length L has a period of 2.5 seconds on Earth. Well, I know what the gravity is on Earth. So if I know what gravity is on Earth and I know what the period is, I can use this equation to solve for the L. Now that L is going to be the same L when I bring it to a different planet because it says it's the same pendulum. So the main thing about a pendulum is what's the length of the pendulum. So I'm going to solve for L, and then once I have that answer, just plug it into the formula to figure the period, to figure out what the gravity is on that other planet. So I'm going to take this, and here's a mistake that a lot of people make. Right now I'm talking over some people, so please try not, when I'm going over this, so that, especially if somebody wants to look at the podcast, they're not like, you hear all this rumbling and talking in the background. So if I square everything here, I'm going to get T squared equals. Here's a mistake that people make, is some did this, but then they did the math wrong, because everything has to be squared. 2 becomes a 4. Pi becomes pi squared. L over G. So that's my formula that's when I take the square of everything. Now, I want the L. So what I'm going to do is I'm going to move the G up there, and I'm going to move the 4 pi squared down there. And when I'm done, I'm going to get L equals G T squared over 4 pi squared. So that's what I'm going to get when I rearrange the equation to solve for the L. I want to know how long the pendulum is that I'm going to bring to another planet to see what the gravity is on that other planet. So I'm going to put in, first I'm putting in right now gravity of the Earth. So gravity of the Earth, 9.8. On Earth, the period is 2.5 seconds. Now I know gravity is going to be bigger on this other planet because it's a shorter period, so it's going to be moving faster to have a period of only 1.6 seconds. I'm going to divide that by 4 pi squared. And, oops, that's squared. And if you solve that, actually I didn't solve it this way. No, I did solve it this way. And I got 1.55 meters. Now, once I have that answer, now I want gravity on the other planet. So I'm going to go back to this equation where it's already been, everything's been squared, and I want to solve for G. So I'm just going to move the G up there, and I'm going to move the T squared down there. So my equation for G on this new planet is going to be 4 pi squared L over the T on this other planet squared. Okay, because it's a different T than the period for the Earth. So I'm going to put in, so everything else is the same though. So 4 pi squared L, so that's 1.55 meters. And we're going to divide that by T squared. But if I put in 2.5 right here, I'm going to get 9.8 as my answer. But I'm putting in the period on this other planet, which is only 1.6. So if I put that in, so I'm dividing by a smaller number that's being squared, I'm going to get a bigger answer for my gravity. And that answer came out to be 23.9 meters per second squared. All right, any questions with that? And again, if you're reviewing this for the retake, you've got, I'll put these up on the YouTube, so you'll have like all the ones that were on the A version, all the ones that are on the B version, other than number 1 on the A version, which I didn't podcast it. All right.